Okay, 8th grade. Let's look at ands and ors. Let's make sure that we understand how we make sense of a problem that is an and question and an or. These are compound equations, compound inequalities, compound statements. That's two statements that are joined by an and an or, and trying to understand what the solution set looks like for these equations. So let's move over to our sketch pad and see what we can learn. Okay, so the question, let's just start off with some basic ands and ors. So let's look at the question, and we did this before in class, but so let's see. I am in English class. Well, yeah, I am in English class or math class. And remember that we asked this question when we were in math class doing math. And so our key operator here, our key compound word here is the word or. Okay, so we're trying to make sense of whether we are in English class or in math class. And think of you right now as sitting in math class, because we're sitting on a video listening to Mr. Lipscomb talk about math. So let's see. Let's ask ourselves the question. Let's look and answer the question, are we in English class? Are we in English class? In English class. And the answer is no, we are not in English class because we are in math class. So we are not in English class, but are we in math class? Whoops. And the answer is yes, we are. And we are in math class. So another way of looking at no, another value for no can be thought of in mathematical terms as false. And in math class, a yes is like a true. So we're in math classes, we're in English class, that's false. And we're in math class is true. So let's look at this equation over here, this statement, I am in English class or in math class. Well, it's like saying, am I in one place or the other? Well, I am in this one of the places. I am in math class. So this whole sentence is true. Because I'm in math class, that makes this sentence true. Now, let's connect that. Let's connect that to the concept of mathematical statements. So these are kind of like logic. This is a logic statement. But mathematical statements can be similar. We can build an analogy, mathematical statements. So let's just look at this statement of x is less than 3. So what numbers make x less than 3? What makes this true? Our solution set is when this is true, our answers are in the solution set. I don't know that I've worded this perfectly well, but you'll know what I mean. Let's look at some answers that are true, that make this true, and some answers that make this, false. So some numbers for x is less than 3 are, well, 2, 1 is less than 3, -5 is less than 3, -1 is less. All of these numbers make this is our sentence, make this true. So what makes this false? Well, numbers like 4, because 4 is not less than 3, 5, 6, 3.5. is not less than 3, and even 3 is not less than 3. So let's look at this on a number line. Whoops, what am I doing? A number line. So kind of what's in the middle is this number 3, 2, 1, and numbers that make it false, 4, 5, 6. These ones don't work over here. These don't work, right? 3, 4, 5, and even 3 doesn't work. So the way that we symbolize that 3 doesn't work is we make our circle here. So 3 is not a solution, but we know that anything like 2 works, 1 works, all these negative numbers work. So kind of anything over here works. So all of these values, so basically values less than 3 make this true. And then these numbers over here, all these make it false. Okay. So let's look at another statement. Let's say x is greater than 5. And I'm just going to cut it short, and we'll say values that make it true are 6, 7, 8. You can figure out why that's true if you need to convince yourself. And numbers that make it false are 3, 4, 5, negative 10. And so if we draw a number line over here, we'd put a 5 in the middle, 6, 7, 8. All of these numbers, 5 doesn't make it true, but all the numbers greater make it true. And then 4, 3, and 2. None of these make it true. So this is nothing new. You probably learned this in 7th grade, 6th grade, how to graph inequalities. But now we need to find the set of numbers that make either one of these true. So we're looking for the problem. I'll write this in a slightly different color. X is less than 3 or X is greater than 5. So what we're going to do here is we're going to make a number line. 2, 3, see, 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. So we'll make these lines like this, and then what we're going to do is we're going to take this thing over here and remind ourselves of what this graph looked like, and we're going to do our graph here and remind ourselves of what this one looked like. And then we need to say, just like up here, we're asking ourselves, all we need is for one of these things to be true. And then we'll have a true mathematical statement. So what are some things that make this left side true? Well, -5, -1, 1, and 2. Remember, anything over here makes this left side true. So part of our answer is going to be anything less than 3. Also, if this right side is true, then this whole thing, this whole question this whole compound statement becomes true. So as long as anything over here is true, our compound statement is true. So here is our final answer. Final answer says, who wants to be a millionaire? Final answer. Anything less than 3 or anything greater than 5 will make this compound statement true. And we did it by analyzing our left side, analyzing our right side, and knowing either side needs to be true. Now, before you think that all or statements will always have this kind of pattern where you're doing an arrow to the left or doing an arrow to the right, don't jump so fast and try and memorize a formula. Memorize instead this rationale. that we just need one or the other to be true. Because I'll give you an example right now where this is not the pattern that is the right answer. So let's get ourselves, oh wait, I learned this new thing. Check this out. We have our new clip art. We can put this cat, this happy cat. The happy cat says, we got the right answer. Happy cat. Okay, now let's build ourselves a new screen, and I want to ask a different question. This question is another OR question, and whoops, get rid of them. Okay, we don't have a happy cat till we get the right answer. So you thought that OR statements all look like this. Remember, this is what our OR statement looked like. That was one example, but I'm going to give you a different one right now. So let's look at this. Let's look at the case where we have x is greater than 5 or x is less than 10. So what are some numbers that are greater than 5? Let's look at what this one looks like. So x is greater than 5 is I'm just going to cut to the chase again and just give you a graph. 4, 5, 6, 7. And I'm going to do x is less than or equal to 10 just so we can change it up just a tad. So here we go. We got our arrow, our graph that looks like this. Everything to the right of 5. Well, less than or equal to 10 looks like, no, it doesn't look like that. It looks like this, 9, 10, 11, 12. Now remember, less than or equal to, we do a dot like this. And less than or equal to 10 is all the numbers over here, like 8, 9, 9.5, negative 4, but everything to the left of 10. Like 11 doesn't make this true. So what we want to do is we want to find what makes either true. And the way that we do that is we come over here and we're going to build a number line. 4, 5, 6, 7, 8, 9, 10, 11. 4, 5, 6, 7, 8, 9, 10, 11. And we're going to graph. We're going to remind ourselves of this graph, and we're going to remind ourselves of, whoops, this graph. Now, everything that makes this one true, all of these numbers over here, but on the right side of 5, make this guy true. So we know that all of this is true because anything that makes the left side true is going to be in our answer. Remember, it doesn't matter what this right side is if the left side is true. Similarly, everything on the right side is all the numbers to the left of 10. So all the numbers to the left of 10 make the right side true. So notice what we have here is that all numbers make this true. So there's no number that is not greater than 5, or one of these has to be true of every single number. Let's look at the number 11. Well, 11 is greater than 5, so it makes this side true. So that works. 7 is greater than 5, and it's also less than or equal to 10, so 7 works. How about 0? All the numbers over here, all these ones way over here. Well, 0 is not greater than 5, but it is less than or equal to 10. So notice that this pattern that we had up here is not fulfilled here. This is a number line where everything is filled in. And let me give you one final example of a problem with ORs where you're going to get a different set of numbers. Try this one. X is less than 7 or X is less than 10. And what you're going to find if you do this one, I'm not going to work it through slowly with you, but I'll just give you the answer. The answer is 7, 8, 9, 10, 11, 6. Here's X is less than 7. And here's x is less than 10. And our final answer is going to look like this. And this, again, an or statement. And I'll leave it to you to figure out why that makes this true or this true. Okay, good. Let's come back. Happy cat. Got the answer right. Okay, new problem. Now we're gonna move over really quickly to ands. An and problem says I am in math and English. Whoops. I am in math, yes, true. But I am in English is false. So am I in math class and in English class? Well, overall, I am not. So this overall statement is false. So remember, with and, both parts must be true. Both parts must be true for and. That's the whole key. So let's look at a problem like this. X is greater than 3 and x is less than or equal to 6. Well, x is greater than 3. We already know what that looks like. 2, 3, 4. X is greater than 3. So that's this. All numbers, 4, 5, 6, everything greater than 3, nothing less than 3. And then x is less than 6 looks like this. Now remember, and both of these have to be true. So let's draw our number line here. Two, three, four, five, 4, 5, 6, 7. So here's x is greater than 3, looks like this. X is less than or equal to 6, solid circle going this way. Now, when are both of these true? Well, both of these are not true over here, not true at 2. Both of these are not true at 7. This is x is less than or equal to 6 is only true in here, and then x is greater than 3 is only true in here. So we need to find the common intersection when both of these have solutions. Well, at 3, the top one isn't a solution, but the bottom one is. So we're going to put an open circle here. Now at 6, both of them are true. And then notice everything in between, both of these things are true. So there's a nice and for you. Right? When is x, just think about it from a logic point of view, when is x greater than 3 and x is less than or equal to 6? Well, 4 works, right? Because 4 is greater than 3 and less than 6. 5 is greater than 3 and less than 6. 5.5 is greater than 3 and less than or equal to 6. So we have our answer, happy cat. Good. All right. Let's do one more and where you don't have this bar pattern. Okay, remember, we just did an and we have this pattern here, and we said, well, we have this bar pattern. 3, 4, 5, 6, 7, 8, 2, 1. But not all ands have the bar pattern. So let's look at one that doesn't have this bar pattern. We're going to say x is less than 0 and x is greater than 3. So x is less than 0 looks like -1, 0, 1. It looks like this. X is greater than 3. Looks like this. So let's put those together. 0, 1, 2, 3, 4, 0. Let's make those numbers just a tad nicer. -1, 0, 1, 2, 3, 4. So here's x is less than 0, and here's x is greater than 3. Now, is there any place where x is less than 0 and greater than 3? Well, -1 is less than 0, but it's not also greater than 3. So over here doesn't work. How about 1? Well, 1's not less than 0, and it's not greater than 3, so the middle doesn't work. And over here, 4, 5, 6, for the same reason, those don't work. So our answer is the empty set. So here's one way to show the answer. Here's a second way to show the answer. Here's a third way to say the answer. There is no solution. And because we got that right, happy cat, you got the right answer here. So remember, sometimes an all ands will have this bar pattern. Sometimes it will have nothing. There's other answers that also other patterns that can work out. But the key is for you to find the overlap of where the two things are true and then to graph that. And if in this case where the overlap is, there is no overlap, then the answer is the empty set or the null set, no solution, a graph with nothing on it. Okay, so that's our lesson for today. Ands and ors. Hopefully this was helpful. Feel free to ask me any questions if you have them. Otherwise, I'll be seeing you in math class. And you know what? I just love you guys because you guys are always so appreciative.